Okay, now let's try a second order differential equation. Let's do this Laplace transform, do the inverse, and let's get the solution to this differential equation. So, first thing is, let's do the Laplace transform. So, we're going to have L y prime prime plus 5 L of y prime plus 4. Now L of y is going to equal 0. Okay? So for y prime prime, that's going to be s squared f of s, now minus s times y of 0 and minus y prime of 0. Okay? Plus 5, that's going to be s f of s minus y of 0, and then plus 4. Now f of s, I'm running out of room, but all of that is going to equal 0. Okay, so that's the Laplace transform of that. Okay, now let's plug in our initial conditions into this problem because we have y of 0 and y prime of 0. So that'd be s squared, now f of s. Now y of 0 is just going to be 1, that's that guy right there, so that's just going to be minus s. Now y prime of 0 is 0, so we're going to leave that one out. And so that's going to be plus 5. Now s f of s minus 1 plus 4 f of s is going to equal 0. We have to fit all of that onto one line. Okay, so the point, at this point of the problem, what you want to do is you want to group all your f of s's together. Let's take one more step. Let's just multiply that 5 through. So we have s squared f of s minus s, now plus 5 s f of s minus 5 plus 4 f of s is going to equal 0. Okay. So we have a negative s and a negative 5 on this side of the problem. Those are the only two terms that do not have an f of s on them. So what we're going to do with those two terms is we're going to move them to the opposite side of the problem. So we end up with s squared f of s plus 5s f of s plus 4 f of s is going to equal s plus 5. Right? Okay, now what we can do is we can pull an f of s off of all of these terms. So we end up with f of s times s squared plus 5s plus 4 is going to equal s plus 5. Okay. So that means that f of s is going to equal s plus 5 divided by s squared plus 5s plus 4. Okay? And we can factor that bottom. So that becomes s plus 5 divided by s plus 1, s plus 4. Okay. So we want to do the inverse Laplace transform on this thing, but what we have to do is we have to do, once again, partial fraction decomposition to break this apart and do the inverse transforms on each of the pieces. So, but the question that we're going to ask is, well, if s plus 5 divided by s plus 1, s plus 4, this is going to equal a divided by s plus 1 plus b divided by s plus 4. Okay? We have to figure out what a and b are. So we're going to multiply both sides of this problem by s plus 1 times s plus 4. So that's going to give us that s plus 5 is going to equal a times s plus 4 plus now b times s plus 1. Okay. All right, now these guys have real distinct roots, so let's just use them. So the first one I would do is let's let s equal -4. Okay. So if I let s equal -4, this is just going to become 1. Okay? This guy's going to disappear. Okay? And then this is going to be -4 plus 1, which is -3. Okay? So you have a -3 and a 1, so that's going to become -1/3. B is going to equal -1/3. Okay? Then I can say let s equal -1. Okay? When I let s equal -1, the term involving b completely disappears. And so we have a, which is -1 plus 4, right? -1 plus 4 is going to be 3. All right, and then s plus 5 is going to be -1 plus 5, and that's going to be, well, 4. So it comes out to be 4 divided by 3. Okay? So that tells me that f of s is going to equal, now 4 divided by 3 times 1 divided by, right like this, s plus 1. And minus 1 divided by 3 times 1 divided by s plus 4. Okay, great. We've got it broken up, and now we do the inverse Laplace transform on this thing to get the solution to our problem. So, L inverse of f of s will equal 4/3. Now, L inverse of 1 divided by s plus 1 minus 1/3 L inverse of 1 divided by s plus 4. Okay? Now remember, it's 1 divided by s minus a, which equals the at. So these are positive, so this is like 1 divided by s minus -1. So that tells me that y of t is going to equal 4 divided by 3 e to the minus t, and minus 1 divided by 3, that would be e to the minus 4t. Okay? And that's it. That's the solution to our problem. So no looking for any coefficients or anything like that. We already got the solution right there.